Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, let us solve the question number 17, NEET physics paper 2015. Students, let us solve the next question, number 17. It says, in a double slit experiment, the two slits are 1 mm apart and a screen is placed in a double slit experiment. This is double slit experiment. This is slit 1, this is slit 2. The two slits are 1 mm apart. So this distance is D, which is 1 mm. The screen is 1 meter away from the slit. So this is capital D, which is 1 meter. This is a screen. A monochromatic light of wavelength, the light that is used is having wavelength 500 nanometer. Okay. What will be the width of each slit? What is the width of each slit? So width of slit is suppose A. A is the width of slit. For obtaining 10 maxima of double slit within the central maxima of single slit. That means if I have a single slit, and I use light of same wavelength, (500 nanometer), then we will have through this slit, if I have a screen exactly here, then it will have its own pattern. This is maxima here. Here, because of this, it will have maxima, then minima, then maxima, and it will have a, in this sense, you will have the diffraction pattern due to single slit. If this is A, width of the slit, and the width of the slit is same as the width of the individual slits of the double slit experiment. So what it talks about is that this portion is known as the width of linear width of central maxima, because this is the single slit diffraction pattern, and here is the width. So within this width, what is this value? If I consider A and lambda as the corresponding width and wavelength of light, I know that for a single slit diffraction pattern, the width of central maxima equals to 2 lambda d divided by A, where this is also capital D, distance. Okay, so this is how you find from here to here it is lambda d by A, from here to here it is lambda d by A, so total is 2 lambda d by A, that is the width of central maxima. Central maxima falls in this region. Okay, now what it says is that within that width, double slit experiment, in this double slit experiment, within that width, within that length, how much maxima is formed? It says 10 maxima of double slit is formed. 10 maxima. Okay, and that means talks about the position of the distance of 10 maxima, whether we count from here to here or you count directly from here to 10 maxima, the distance will remain the same, because we are interested in 10 maxima. The distance between any maxima to any maxima, if I consider 10 maxima, then that distance, within that distance I have to put 10 maxima, 1, 2, 3, 4 like that. and this distance is known to us that for ten maxima, that is 10 bright fringes for Young's double slit experiment, the distance is for 10 bright fringes to be formed, the distance is 10 lambda d by d, because xn is n lambda d by d, where this lambda d by d is the fringe width or bright fringes or dark fringes. Any fringes will consider the distance between successive bright fringes or dark fringes is the fringe width. Now, so here if I talk about this is central bright fringe, then first bright fringe here, second here, third here, suppose this is the 10th one, then this distance is x10, and that is defined as 10 lambda d over d. So this distance occupies this is the position of 10th maxima, and this distance is exactly equal to this distance here, because I want 10 maxima here, 10 maxima here due to single slit. Due to single slit, I will form here, this is the 5th and this is the 5th. So this is 10th maxima is formed within this. So I have to, so exactly within its central maxima, 10 bright fringes are formed due to this one. So that means the distance between the 10th maxima, okay, or the position of 10th maxima from central maxima, this distance is equal to the width of the central maxima of single slit. So this and that are same, it's matching. So if it is matching, then we'll equate that. So according to question, according to the question, 10 lambda d over d is equal to 2 lambda d over a, where a is the width of the slit, d is the distance between slits in Young's double slit experiment. So if I solve this, then obviously we'll cancel lambda d. This is 5, so a will be d over 5, and d is in mm, d is in mm, there is 1 mm, so you can see here d is 1 mm, so this is 1 by 5 mm, which is 0.2 mm. So that is the width of single slit. So the question is, what will be the width of each slit? That is coming out to a 0.2, as we have found here, it is 0.2 mm. So the answer is 0.2 mm. So this is the right answer to this question. Okay, thank you.